All right, everyone. Thank you for coming out to today's Tech Talk. Up today, we have Michael, who's going to be giving us a Tech Talk all about WebSockets. Take it away, Michael.
All right, thank you very much. Can you guys see my screen? Oh, actually, hold on one second. Oh, okay, cool, perfect. Well, hey everybody, I am Michael Filoramo. Thank you so much for coming to my Tech Talk on WebSockets, and I'm super excited. But before we begin, I'd first just like to start by thanking SingleSprout for sponsoring this Tech Talk. And I'd also like to thank CoSmith for having me here. So, in a nutshell, a WebSocket is basically a communications protocol that allows for open, two-way interactive communication sessions between a client and a server. And using this protocol rather than, for example, HTTP, it allows users to send messages to a server and receive event-driven responses without having to poll the server for a reply. And polling a server is basically when a client asks a server for new data regularly. So before we dive into WebSockets and their awesome design and functionality, first I just want to bring some familiar concepts into the spotlight just for context, just so we can truly appreciate the speed and efficiency of WebSockets. So in order for computers and other communication systems to talk to one another, we need some kind of a standard protocol, right? And a protocol is just basically a system of rules and expectations that two machines can use, to understand what the heck the other one is saying. Some protocols that you might have heard of are HTTP, TCP, UDP, SSL, IMAP, and POP for email, etc. So it turns out actually that there are a lot of different protocols that exist on literally every layer of the internet. So the International Organization for Standardization created a model called the OSI model. OSI stands for Open Systems Interconnection. And it's basically a model that stratifies modes of internet communication at all layers. So you see here, there's the physical layer, the data link layer, etc. I'm not going to talk about all the layers, but the application layer, the topmost one, that is where things like HTTP happen, or SSL, or IMAP. And of course, that's where WebSockets happen too. So to give you a better idea of WebSockets advantages and how WebSockets differ from other application layer protocols, just want to do a quick comparison with two other protocols that most, if not all of you, have heard of before: HTTP and AJAX. So in HTTP, or Hypertext Transfer Protocol, right? Client sends a request to a server with some information attached, server processes it, server sends a response to client. And at this level, like, the response can be anything, like any type of data. But I mentioned HTTP because its differences to WebSockets really drive the point home here, right? HTTP, on the one hand, is stateless, meaning like after a request or response completes, there's no connection anymore, right? It's gone. But in WebSockets, this is completely different. The connection persists until one side decides to voluntarily terminate it. Another example, in HTTP, right, you have to specify an action, or basically like the intention of your request. Are you trying to fetch data? Are you trying to submit data, modify it, delete it? Because if so, you have to specify it with the get, post, put, delete keywords. And actually, there's a bunch of others. It's kind of crazy. They're not conventionally used as often, but that's a whole separate story. And again, this whole thing with all these header keywords, it doesn't really exist like this in WebSockets, but you'll see what I mean in a second. On the other hand, right, there's AJAX, which stands for Asynchronous JavaScript and XML. And with AJAX, now web pages are able to be updated asynchronously, right, meaning non-blocking, by exchanging data with a web server behind the scenes. So now, right, we're able to update parts of a web page without reloading the entire thing again. And basically, like, the key advantage here is now we can send multiple requests without having to worry about blocking future communications between client and server. And what makes it so cool is, like, now data is kind of exchanged in real time, right? But is it really real time? That's kind of the question. Well, what if we had a communications protocol in which, as the client, right, we request data from a server, the server gives us data back, but suppose the server wanted to send us more data, it can do so freely and without additional requests from us, from the client, right? What if on the server side, we wanted to send data to everyone who was connected with us? Well, the answer enter WebSockets. So WebSockets are the solution to this problem of not being able to, conventionally have a truly real-time connection between the client and the server, or of not having to keep sending requests upon request, not having to wait for responses, or not being able to get more responses in spite of us not sending requests, right? WebSockets is kind of our solution here. So WebSockets then are, as I said before, a communications protocol in which the client and the server share what's called a full duplex communication connection, or basically bidirectional. Client can send data to server, server can send data to client, and this can happen interchangeably and at the will of either party. Okay, there doesn't have to be like requests sent out or response cycles to finish. It's just free communication essentially, but it's still a protocol, just like HTTP. And fun fact, instead of WebSocket connections starting with HTTP : they actually start with WS : I just thought that was cool. Whatever. Anyway, unlike HTTP, right, a WebSocket connection request only sends headers once, which makes it kind of faster in that regard. But believe it or not, it actually only sends one header, which is when the client asks the server if it can upgrade from HTTP to WS. And I swear, this is actually called the WebSocket handshake, believe it or not, WebSocket handshake, I don't know. So rather than just talk about it, I'm just going to give you a little sneak peek as to what it looks like in code in the Node.js environment. So on the back end, this is what like a super basic implementation of a WebSocket server would look like, right? First, we would import in or require in this case, I'm using WS. There's actually many different WebSocket libraries. In this case, I'm just using WS, which is a very popular one, right? I declare it as WebSocket, I require it in, and it's pretty easy to spin up a server. I just, sort of like in the native Node.js environment, right? I spin up a server by declaring new WebSocket, and I invoke the server method, and I only give it one argument, just the port, right? And I give it to it as an object. And then I put an event listener, and I say, server, when you hear connection happening, which you just defined with a string connection, then we're going to do something with a socket. What are we going to do? We're going to initiate a socket, and then on the socket, we're going to put an event listener, and we're going to say socket on, and if you get a message, take the message and then send it back to the client and say, Roger that, and just repeat the message the client sends to you. That's pretty much it. That's a whole backend WebSocket. So on the front end, this is what it would look like, right? We obviously want to tell the front end, well, there's going to be this thing called a socket. It's going to be a WebSocket, and it's at this host name, right? WS, blah, 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 localhost 80. And now we want to listen for messages from a server. So we put, and this is actually a correct syntax, because in this library, they don't use camel case, I don't know why. But we say socket, when you hear a message, all right, take that message or that data and console log it. Say, hey, we got a message from a server, and it is this, whatever the server sends us. That's it. That's basically it. But supposing, right, we didn't want to wait for a response. We didn't want to wait for a message to be sent to us from the server. Supposing we wanted to send stuff back to the server from the client side. Well, let's say we had a button, and then when we click the button, right, we want to send a message to the server. That's fine. So we'll use some vanilla DOM manipulation, and we'll say, when we click that button, send through that socket to the server, hello. And that's, of course, on the back ends, it would say, Roger that, hello. That's it. That's what this whole WebSocket thing is. On a very basic level, of course, WebSockets does get pretty advanced. So let's just see what that would look like. Well, these three windows are clients, and each one is connected to a server, okay? One server. So it's a chat app, which is one of the most common implementations of WebSockets, right? So in theory, when any one of these clients sends a message, the other two should be able to see it, and three if you count the one who sent it. Well, let's see. This is what it would look like. The first one to the left says hi, so everyone says they say hi. And then they say hello, the second one. And the third one just kind of doesn't say much, and then says howdy, right? But you can see each person is a separate client, each person is saying something different, and everyone can see it all at once. That's pretty much it. So when it comes to use cases for WebSockets, here's how not to use them. You wouldn't use them as a complete replacement for HTTP, as cool as WebSockets are, mainly because there's actually a handful of benefits that WebSockets does not have built in that HTTP actually does. No offense, WebSockets. Like automatic caching for things like REST and OAuth. And also, like, load balancing a WebSocket connection is sort of cumbersome and requires like an exhausting amount of configuration, which obviously hinders deployment. So there's that. But how to use WebSockets, right? Some reasons you would implement them is when you actually need, right, those beautiful and instantaneous full duplex connections, right? And you'll usually find this in chat applications, web-based games, live streaming, push notifications on your phone, tracking stuff, right? Financial updates like stocks, cryptos, sports updates, pretty much anything that absolutely needs a low latency, real-time connection. So before I end this tech talk, I just want to, or terminate my connection with you all, ha ha ha. I just wanted to mention some popular and beautifully engineered Node.js-based WebSocket libraries that are used a lot these days. And I actually use one of them fairly often in my work. First one's Socket.io. This one's my personal favorite just because it abstracts away very elegantly language for a WebSocket implementation. And it also happens to be one of the most popular WebSocket libraries. It's about 55,000 GitHub stars, whatever. And it's reliable. It has tools for load balancing, binary streaming support, handling proxies, other nifty features too. And it's even used by companies like Trello and Microsoft. WS is probably, that was the one I was using before. That's probably the most popular one, weighing in at about 35 million weekly downloads on NPM. Chances are at least several of us in the room have used it before. Super fast, super easy to use, great documentation, very well tested, has a great community. And then Socket Cluster is interesting. I haven't actually used it, but I've read that it's great at scaling. And what sticks out to me about it the most is its ability to build multi-process real-time servers that use all of the server's available CPU cores at once. And this is cool because it allows the backend to avoid running Node.js exclusively as a single-threaded environment, which would be a nightmare at those scales. So yeah. Here's some resources for you to check out if you're interested when the slides come out. These helped me a lot when I was first learning WebSockets in, I think it was Scratch or Solo, I forgot which, but either way, very helpful resources. So check that out when you have some time if you're interested. And to end, I just want to sincerely thank everyone at Codesmith for being the most incredible friends and classmates and instructors and staff, and for giving me the opportunity to, ramble about WebSockets for 15 minutes straight. So thanks, Codesmith. And thank you all so much for listening.
Awesome talk, Michael. Thanks so much. And we do have time for one question if anybody has a question for Michael about WebSockets. All right, looks like you answered all the questions, Michael. So great job and thank you so much.